Hello and welcome everyone to Chapter 8 of our C Programming Explainer series. We are jumping right into the good stuff today. If you've ever wondered how computers process text, handle names, or read entire sentences, well, you're exactly where you need to be. Today, we're mastering strings.
But before we dive into strings, let's take about 30 seconds for a quick recap of what we covered in Chapter 7. Remember arrays? An array is just a collection of similar data types stored together in contiguous memory blocks. Think of it like a giant continuous row of lockers. Last time, we looked at integer arrays, like int marks 90, which we use to store numbers sequentially. Now, what if we want to store letters instead of numbers? Well, a string is literally just the natural evolution of that array concept. Instead of a locker full of integers, it's an array of characters, like char name 20. It really is that simple.
Here is our roadmap for today's explainer. We'll go from arrays to strings, look at strings in memory, tackle input and output, explore pointers and declarations, crack open the string.h library, and then wrap things up with a preview of Chapter 9.
All right, Section 1, Arrays to Strings and Memory.
Okay, let's really dive into this. By definition, a string is just a one-dimensional character array. But there's one absolutely crucial detail. It is always terminated by a null character, which we write as a backslash followed by a 0. Now you might be wondering, why on earth do we need a null character? Well, imagine your computer scanning through a massive row of memory blocks. It needs to know exactly where your specific word ends. If it doesn't have a stopping point, it'll just keep reading right past your word and accidentally pull in random garbage data left over in the next memory blocks. So, that null character is essentially a stop sign. It literally tells the computer, hey, the text ends right here.
So, how do we actually write this in our code? Well, the manual way to initialize a string is honestly kind of tedious. You have to put every single character inside single quotes, separate them all with commas, and then manually type out that null character at the very end. But luckily, there's a double quote shortcut. When you type char s equals Harry inside double quotes, the C compiler does something awesome. It's smart enough to automatically add that null character at the end of the array for you in memory, saving us a ton of time in typing.
Moving right along to Section 2, Input and Output Operations. To output a string to the screen, we rely on our trusty printf function. But this time, instead of %d for integers, we use the %s format specifier. This tells the computer to print the whole array of characters until it hits that null character stop sign. And to take input from a user, we use scanf with that exact same %s specifier. Now here's a really cool behind-the-scenes detail. When your user types a word and hits the Enter key, scanf automatically tacks on that null character for you in memory. However, scanf does have one major glaring flaw. And that flaw? It's spaces. Let's say you use scanf to ask a user for their full name, like Harry Potter. Scanf will actually stop reading the exact moment it sees the space between a first and last name. It just cannot handle multi-word strings. That is exactly why C gives us two dedicated functions, gets and puts. Get is specifically designed to read an entire multi-word string, spaces and all, and puts is a super convenient way to output that string back out. As a bonus, puts automatically places your cursor on the next line after printing, which saves you from having to manually type out an annoying new line character.
Let's just take a quick breather here. If you have any questions or doubts, leave them in the comments. Your question might be answered in a future explainer. Programming is all about building strong foundational blocks, so we want to make sure you're feeling totally confident before we move forward.
All right, Section 3, Pointers and String Declarations. So, the absolutely crucial point here is how memory handles these declarations. Once you define a string using standard array syntax, like char st equals Harry, it is locked in. It is physically placed in those specific memory blocks, and you cannot reinitialize that variable to hold a completely different string later in the program. But if you declare it using pointer syntax by placing an asterisk before your pointer name, like char ptr equals Harry, you're doing something different. You are telling the compiler to store the string in memory, but just give your variable the address of where it starts. And because a pointer just holds a memory address, you can completely reinitialize it later to point to a brand new string, like Rohan. It gives you an incredible amount of flexibility as a developer.
Now for the really fun stuff. Section 4, Standard Library String Functions.
Welcome to the C Developer's Toolbox. By simply including the string.h header file at the top of your code, you instantly unlock dozens of powerful pre-written functions. We are going to focus on the 4 absolute core ones today: string length for finding string length, string copy for copying, string concatenating or combining strings, and string compare for comparing them. Let's break these down line by line.
First up is strlen. You pass it a string, and it counts the characters and hands you an integer back. Now, importantly, it excludes the null character. It is only counting the actual visible text. Next is strcpy, which copies the exact content of a source string directly into a target string. Now, I have to give you a massive warning here. Your target string array must have enough capacity to hold the source data. If your target array was initialized to only hold 5 characters and you try to use strcpy to cram 20 characters into it, you are going to overwrite other random pieces of memory and your program will absolutely crash. Always check your capacity.
Next up, we have strcatc, which is short for string concatenation. This literally glues the second string right onto the end of the first string. So if string 1 is hello and string 2 is Harry, passing them both into strcat modifies string 1 to become hello Harry. Notice anything missing? There is no space between the words. The function just bluntly connects the exact characters you fed it. It doesn't care about formatting them nicely for human readability. If you want a space, you have to add it yourself.
And this brilliantly illustrates how computers actually read text. strcmp compares 2 strings to see if they match. But how does it do that? It checks them character by character based entirely on their hidden numeric ASCII values. If the 2 strings are exactly 100% identical, it returns a 0. If there's a mismatch, it compares the math. If the first string's character has a lower ASCII value, the function returns a negative number. Otherwise, it spits out a positive number. At the end of the day, text is all just math under the hood.
Let's talk about putting this into action. Section 5. Practice and exercises.
Coding is a hands-on sport, so here are a few amazing challenges from the chapter's practice set. I highly recommend you try to build your own custom version of string length from scratch, using a loop to manually search for that null character. Also, try creating an encryption function. Since we just learned that characters are really just ASCII numbers, you can encrypt a whole string by writing a loop that simply adds 1 to every character's value. An A becomes a B becomes a C. Then, write a companion function to subtract 1 and decrypt it back. It is a fantastic, practical way to master memory and character arrays.
Almost done. Section 6. Wrap up and what's next?
Let's lock in everything we learned today with our 5 key takeaways. Number 1, strings are just 1D character arrays that strictly end with the null character stop sign. Number 2, never use scanf for multi-word strings. Use gets to capture those spaces. Number 3, declaring strings using pointers gives you the magical power to reinitialize them later on. Number 4, always make sure your target arrays are big enough when copying data to prevent disastrous memory crashes. And number 5, remember to include the string.h library at the top of your files so you don't have to reinvent the wheel for basic text manipulation.
You guys did incredibly well today. That was a lot of memory management to absorb. If you're enjoying this C programming series, don't forget to like the explainer and subscribe for upcoming chapters. It really helps out and ensures we can keep this structured learning coming your way. Before we go, I want to leave you with a little puzzle to think about. We know that arrays and strings hold similar data types, right? They are either all integers or all characters. But what if we want to build a profile for a company employee that includes an integer for their ID number, a float for their salary, and a string for their name? How on earth do we group dissimilar data together in C? Well, that is exactly what we are going to uncover in Chapter 9 when we explore structures. Until next time, happy coding!